This is a hoverboard hub motor. I'm going to modify it for use in electric vehicle. So this is how it is before the modification. I'm going to test it as it is now. The wires that come out of it, the 3-phase wire and the Hall sensor. But after modification, I'm going to let go the Hall sensor. I'm not going to use the Hall sensor because I need the space occupied by the wire that comes out by the Hall sensor. Because I'm going to increase the sizes of the wire so that it can give me more output. Now let's go and test it like this. This is how it is. First, I'm going to test it as a generator. I'm going to connect this 180 watts incandescent lamp, car incandescent headlamp. This is 60 watts, 60 watts, 60 watts. That's 180 watts. So I'm going to connect the tray to the 3 phases to see how it performs. Then we'll compare it after I modify it to the results. So I've connected the bulb. It's very hard to turn now. Very hard to turn now. But I'm going to try to turn it. Generating enormous power. Let me switch off the light. That's it. All the 180. So now I have set up the motor with a BLDC controller for 12 volts. 12 volt battery is there. This is the potentiometer. If I'm turning it, it should start moving. That's the highest. That's the highest. High torque. It has its own torque already. You can't stop it. That's it. So this is how the inside looks. The wires are thick enough for the purpose it is meant, but if you want it to serve more, you have to rewind it with the thicker wire, maybe multiplied by 2 or multiplied by 3, depending on what you want to use it for. So I made this 6000 watt brushless DC motor from drum motor from washer machine, but I didn't have differential gear, so I use this, but it's not enough, and I don't want to use differential gear because of the weight. I'm trying to reduce the weight as much as possible so that my range, the target range that I want for this vehicle, will be achieved. I have panel, but I need something light, so now I have to design a direct drive motor from a hoverboard equipment. So I'm designing a direct drive motor for the 2 rear wheel. So I have to do this.
I have to do this. So that's what I've been doing. It will take me time, but I will do it. And because I decide to do it, so I'm going to do it.
So after modifying it, this is how it comes out. Just change the wires. So the output wire, I have not insulated it properly. I'm going to do that, but I want to test it with the, I think compare it with how it was before I complete the work. So this is it.
So I connected the same load as I did before. So I'm going to use hand to turn it and see. I'll off the light again so that you can see it. See? I think it's the same brightness, the same generating force. So I've connected it again to the same controller, the same battery input. Now I'll turn the potentiometer. This is more speed. This is multiplied by 3 of the speed. The torque remains the same, or even more torque. It will take me. It's powerful enough to take me off my feet. That's how powerful it is. I love this. See the speed, see the torque. It's shaking the table, you see? Shaking everything. Okay. If you want to learn how to do this, we do it in the class, one-on-one. I'll teach you how to do it. Yeah. Just let me know. I'll transfer the knowledge. So now I have now fixed the hoverboard motor to this wheel. So I remove the front wheel and putting it on the front wheel instead. Putting it in the front wheel. So let me check it. This is the other one. I'll check it now. I've connected it to 12-volt battery. I want to know the consumption, so I put it on amp meter. Can go to 20 amp maximum. So when I on it here, it's using 0.47 to run it to 10. 0.47 multiplied by 12 volts. You know what that is? That is less than 5. That is around 5 watts. That is turning this guy 5 watts. So if I apply load like this, it should increase. So it's increasing depending on the load. So when it's on the road, it will definitely take more than 5 amps. So when we fix it, we'll get back to you. See, when it's starting, it takes more. That's the starting. So then you come down to relax at 0.47, 0.46.